Hey there guys, Mr. Mice is here, and I am going to talk to you about displaying univariate quantitative data. So basically, we're looking at what kind of displays do we use to display quantitative data that's one variable. That's what univariate stands for, one variable quantitative data. And some of you have seen this. They're different than what we would use for categorical data, which I went over in a previous video. So let's take a look at a few examples of where you would display quantitative data. These are a few. I'll have a video of one that I don't go over here called box plots and box and whisker plots. It'll have its own video because building one of those is a little bit of a task. There's a lot of other stuff that goes involved with a box plot. So let's take a look at a few of them. So first one that we have is called a dot plot. And a dot plot, look at, if you notice here, these are the number of books that somebody read last summer. Not somebody, but other people, like numerous people. So, you know, one person said they didn't read any books, and another person said they didn't read any books. And it looks like 4 dots, a dot representing each person in this case that read that many books. 4 people read 0 books, whereas 6 people read 1 book, and so forth. So basically, we're just going to put a dot where we want to show our frequency for the number of books read last summer. Now, the thing about a dot plot that you need to be aware of is the dots really should be the same size. We don't want this dot way bigger than this dot, smaller than that one, bigger than that one, because then we end up with something that really, since they're not the same size, we can end up with something that's really deceptive. And that's often called the area principle. So, you know, we see that all the time. If you ever look on, you know, politics like to do a lot. They like to put up things that are a little bit deceptive, and they use the area principle by doing that. So we want to make sure that our dots are all the same size and basically on the same parallel to one another, okay? Let's take a look at another one. That's called a histogram. This is one of our most popular ones that we see. And the histogram, it looks a lot like the dot plot. So we look at the dot plot. You know, we've got almost a histogram. If we took squares, rectangles, and we just put rectangles around these dots, we end up with this histogram. Now, the histogram displays quantitative data. In this case, we have frequency on this side, and these are our bins. Now, our bins are kind of what values do this rectangle represent. And so between 60 and 119 minutes, we have 13 people that fall somewhere in there in these numbers. Now, it looks like, oh, wait a minute, this is a bar chart, and these are categories. No, they're not categories. These are numerical data. Now, okay, time out. This one here actually is a category because it's 240 plus. Now, we don't really do histograms with 240 plus, right? So what I would recommend, if I saw this on one of my students' papers, I'd say, you know what? This needs to be 242 whatever, right? In fact, what I would actually prefer is if she put values on this number line on the x-axis, because then it makes it a histogram, and these bin sizes will be relatively the same number. So they're the same bin size. A lot of times we use the left-hand convention. Basically, that means that anything on the left side of this number is going to go in that rectangle. So 119 is going to go in this rectangle. This is a value of 119. Anything above 119 is going to go here. Anything above 179 is going to go here. She already cut those off like that. But rather than put them like this, I would put 60 and 119 here. All right, that's a histogram. We also have a stem and leaf plot. So this is hours of homework per week that somebody's done. Now, a stem and leaf plot, it looks basically like a histogram or a dot plot on the side, except we're actually showing the actual data. So this is where our stem is going to go. Kind of, if you think of a tree, this is the stem, and coming off the stem are a bunch of leaves. Now, we always have to have a key somewhere to let us know what that stem and leaf represent. In this case, 1 with the bar 5 represents 15 hours. Because if I didn't put a key, how do I not know that this is 1.1 hours? or 101 or 110. I don't know where my decimal would be in this case, so I wouldn't know what these data really even represent. And I need my context here to really tell me what they represent, because remember, numbers without any context are really meaningless. We really need some sort of context to look at. So with a stem and leaf plot, we want to make sure that we have our stem and leaves, and we make sure we have our key in context. One other thing you might see on here is that I have a little star. What this means is I have like 4 hours, and then anything between 0 and 4 for my digits will go here. Anything 5 and 9 will go here. So here, everything 1 to 4 goes here, 5 and above goes here. So this means 15, 15, 16, 16, 11, 11, 12, 14, and so forth, okay? That's a stem and leaf plot. The next one we have is a time plot. Now, a time plot, it wouldn't make sense for us down here with dates to put a histogram, because it really, you know, this needs to be a number line. So a time plot is quantitative data, right? On the 29th, we had, you know, 1.25 hours spent doing homework or studying, or this looks like 1 point maybe 7. On the, you know, and then on Monday, the next day, or 2 days later, I didn't spend any hours doing homework. Another day later, I did a little bit more, but man, I must have been loaded on the 3rd. On the 3rd, my homework just increased, and then I took a dip down and so forth. We can see how much homework I'm doing as time progresses. So a time plot really has to do with what's the trend as time increases. What's the trend over time of my hours spent doing homework? Now, the one other one that I did not include was the box plot, and the box plot will come into play later on. It is a source of one. It is a display for one univariate quantitative data, but we'll do that on a separate video. All right. So these are 3 types of displays that you'll be using with quantitative data. Talk to you later, guys. Bye.